Hi, good day to you guys. So today we're going to learn about physics. So before we begin, let's study first what is all this subject about. So physics stems from the word physike from Greek, which means the study of natural phenomenon. So physics study from everything that you can see to everything that is above you, which is in the outer space. And it is believed that physics is actually the oldest form of science if we include astrology. So physics, they are explained by three things, which is the hypothesis, theory, and law. Hypothesis is something that you derive from your own observation. For example, if I see a bird with wings, my hypothesis would be that the bird can fly. But is it proven? Not necessarily. So what happens is, a theory is something that is developed when the observation, the hypothesis, is proven. So if, let's say, the bird can fly, the theory is that the bird is utilizing the wings to make the draft beneath the wings to allow the bird to reach a greater height. And then you have the law. Law is something that includes a mathematical explanation to what you just observed. So physics consists of hypothesis, theory, and law. So let's start with something that you will learn and use until the end of your Form 5. So physics have their own physical quantities. So physical quantities are separated into two categories, the basic quantities and the derived quantities. But first, let's start with the basic quantities. So the basic quantities consist of 7 types. So the first type, so we have our mass. The symbol for mass is m. The SI unit is kilogram. And the SI symbol is kg. And then we have length. And the symbol for length is S. The SI unit is meter. And the SI symbol is m. Next, we go with time. The symbol is T. The SI unit is second. And the symbol is small s. Next, we go to current. The symbol is I. SI unit is ampere. And our SI symbol is A. We have temperature. The symbol is capital T. The SI unit is Kelvin. And the SI symbol is K. Now, I know this might confuse you because you are used to temperature being a unit that we have been using for quite some time, which is degrees Celsius. But for physics, we use the temperature in thermodynamic. And in thermodynamic, our temperature is always in Kelvin. You will see later in chapter 4 that we still use degrees Celsius in certain part of the equation, but mostly for calculation involving physics, we are going to stick with Kelvin. So how do we convert from degrees Celsius to Kelvin? Degrees Celsius, when we are converting it to Kelvin, we add with 273. And from Kelvin, changing to degrees Celsius, we deduct 273. Right, next, from here, we have two more, which is the number of substance, which is N, and the SI unit is mole. The SI symbol is also mole. And lastly, we have light intensity. The symbol is L, luminosity. The SI unit is candela. And the SI symbol is CD. So these are the 7 basic quantities that you will use throughout your studies of physics, and you will also notice it in biology and chemistry. Why? Because we use these basic quantities to explain myriads of different observations as well as involving in our calculations. So these basic quantities can be combined between one and another to form derived quantities. Everything other than these 7 are basically derived quantities. And derived quantities have a lot. So I'm just going to cover a few with you guys today, because as we go along through our physics studies, we're going to notice that we're going to learn more of the derived quantities. So I'm going to start with the most basic one. F equals to ma. You've already learned this during your Form 3 science studies, where force is a product of mass and acceleration. Now, here you have another derivation. An acceleration is consisting of the length and time square. So if I were to use the symbols for this one, it would be something like this. So usually for objective questions, they're going to give you something like a symbol, and they ask you to describe which derived quantities that represent the symbol. All right, we have pressure. Again, this is something that you already learned. In pressure, it is actually mass over volume. And we know that volume is basically length times width times height. So mass over length to the power of 3. So it's going to be m over s cubed. All right. And lastly, I'm just going to touch one more. We have momentum. Momentum is a product of mass and velocity. So we have m times velocity is length over time. So length over time, you're going to have mlt. That's why if we break it up into their own respective SI symbol, we're going to have something like this. kg m s negative 2. The pressure will have kg m cubed. And this one will give you kg m s negative 1. So these are the derived unit. And here you have the basic unit. When you combine several of these basic units, you're going to get your derived quantities. Stop.
Go.
Okay, now we're going to go for prefixes. What are prefixes? So prefixes are just representative of a larger number. So we use prefix to make our writing simpler and to make it look much more neater. For example, when we look at tera, the symbol is T. It represents 1 times 10 to the power of 12. Or if we were to write it in the long form, it is 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So quite long to write it in a single sentence. So what we do, we replace it with the symbol. So for example, let's say the voltage or the power produced by a power plant is around 2 terawatt. This is much neater than if I were to write 2000000 watt. So we use prefixes in science to make the writing much more simpler to understand, because each one is designated to a specific set of unit. So when we look at giga, the giga is G. It is 1 times 10 to the power of 9. So this is basically a 9 of zeros. Mega, 1 times 10 to the power of 6. Kilo, 1 times 10 to the power of 3. Hecto, 1 times 10 to the power of 2. Deca, 1 times 10 to the power of 1. And then we go with the smaller unit. Now we have deci, D. 1 times 10 to the power of negative 1. Centi, 1 times 10 to the power of negative 2. Milli, 1 times 10 to the power of negative 3. Micro, 1 times 10 to the power of negative 6. Nano, 1 times 10 to the power of negative 9. And pico, 1 times 10 to the power of negative 12. Now, in physics, sometimes we have to convert from one prefix to another prefix. So I'm going to teach you a much simpler way to do this without confusing yourself. So let's say I'm giving you conversion of prefixes. Now, let's say I have 1 micronewton. From this micronewton, I want to convert to kilonewton. So what you need to do is you put here 1, expand the micro. So it is 1 times 10 to the power of negative 6. Expand the kilo. You're going to have 1 times 10 to the power of 3. Now, if it is a division, we deduct the power together. So you're going to have 1 times 10 to the power of negative 9. Because negative 6 minus with 3, you're going to get negative 9 kilonewton. So whatever the question gives you, straight away put in the unit representing the prefixes and put it underneath it. Expand the unit of prefix that is given in your equation. So if I were to give another one, let's say I'm converting 0.8 hectopascal to millipascal. So hecto is 1 times 10 to the power of 2. So 0.8 times 1 times 10 to the power of 2 divide 1 times 10 to the power of negative 3. Because we know that the milli unit is negative 3. So when we divide this, 2 minus negative 3, you're going to get 2 plus 3, which is 5. Now this can be moved, this decimal can be moved to the right. You're going to get 8 times, this is 1, negative 1, and here becomes 1 minus negative 3. You're going to get 10 to the power of 4 millipascal. And this is the easiest way you want to approach this question when you have to convert from a smaller prefix to a larger prefix or from a larger prefix to a smaller prefix. Straight away, expand your prefixes and then you divide with whatever the prefix that you want to convert into. And done. Right, now we're going to go with the scientific explanation. So experimentation, how one need to carry out experiments to prove their theory, their hypothesis, or their law. So in any settings of scientific endeavors, regardless it's physics, chemistry, or biology, we carry out experiment in the same manner. So the first steps in carrying out any kind of examination or experimentation, it always starts with an observation. An experiment cannot be carried out unless an observation is done. So usually for an observation, we observe something that is happening and we try to prove it or to make sense of it. So in an observation, let's say we saw an electricity passing through a circuit. So our observation is electricity pass through and the bulb light up. So this is the observation. So when we have an observation, the next step that we need to do is to form a hypothesis. So the hypothesis that we derive from here is that the bulb only light up when the electricity is present. So we can say that bulb light up due to electricity. Now, once we have our hypothesis, we start with designing our experiment. So we start with our aim. So our aim would be to study the effect of electricity on light bulb. So here, for aim, we start the sentence always with to study the ... And then relate whatever your theory is to your observation. So our theory is that the electricity is needed